Okay, 1, 2, 1, 2. Oh, and addio. Test. William, I think 1, 2, 1, 2. Probably, I don't know. Can you take a look? Thank you.
Hello. 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 Whoa.
Hello.
You can use this.
Okay.
Thank you. So, are we guys ready to continue? Just really quickly, so that we close B2, there is a final thing that exists at the bottom of your what is it called? Let me find it. At your Sui primitives.move file at the bottom, you see that we are showcasing dynamic fields and dynamic object fields. Anyone who has already worked with those, just raise your hand. You don't have to tell me. If you have worked with dynamic fields or dynamic object fields. Okay, I see a few people. Cool. So, the main concept would be, and I'll also share documentation on the Telegram chat for you guys in case you want to take a look later at your own time, that you want to extend the fields of a predefined struct, let's say. Move gives you the opportunity to do that, Sui and Move, of course, to do that by utilizing dynamic fields and or dynamic object fields. The difference between the two is basically that with dynamic object fields, you're also creating an object that is basically attached on a parent object, right? And has some fields that extend the parent object's, let's say, functionality in a sense. With dynamic field, you are just attaching fields that are not an object themselves and are not basically traceable on the network. So, just so that we showcase this, I have prepared this example and we will go through it line by line. If you have any questions, feel free to stop me. So, once again, we are initializing a test scenario like you remember we did yesterday. We call the begin function and we give as argument an address. I remind you that annotating with the @ sign a dummy address, this is just a dummy address, we are giving this an address and we are beginning the scenario. We're saying that this is the actor of the scenario, the main actor. So, we are also initializing a container that we will set as mutable because we will change the contents of this container. What this container is, it's just a struct that we have declared on top. It has the key ability. So what does that mean? The fact that it has the key ability in an ID, what does it mean? It's an object on chain. Yes, this is basically what I was looking for. Thank you all. It's an object that will live on chain, basically. So we are initializing a new container here. We are getting the we are creating a new ID by this function as we did yesterday, providing the context. And now let's work a bit with dynamic fields. I remind you what we said is because we would like to extend, for example, the container struct without, we would have a reason not to change this itself, but extend it, let's say. So, by utilizing the dynamic field module, we are getting the add function from the dynamic field module, and if we were to click inside here, and see this add function, we see add the dynamic field to the object at the field specified by name. So, to this object, which we should pass it, as we see here, as a mutable of the ID, and that's what we're doing, a mutable reference to the ID. We pass a name of the new field and the value. This is just 100, strictly typed as a U16, U64. So, just that. Like that, we just added a new field by utilizing dynamic fields. I remind you that in this business case was like that we wanted to extend the container struct. We do it like so, then on the next line, we are actually utilizing the borrow function of dynamic field in order to get the value that exists inside the score field. Let's go ahead and read these two. Let's look into borrow. Immutably borrows the object dynamic field with the name specified by name. Immutable borrow. We also have a mutable borrow in case we want to change this value. Here we are just only reading it, right? We're just going to be asserting that the score is indeed 100. We are not going to be mutating it. If we wanted to mutate the field of the dynamic field called score, we would use the other function just above, which is called borrow mutable. So we are borrowing, assigning to the score variable, and then checking that it is indeed 100. Why? Because we've set it here. So what these three lines are basically saying is extend the container. After you extend the container with the new field called score, which has the value 100, take it back. So this borrow means that if I read it, if I have a value inside the score, that means that my line above was executed successfully. So I assert that everything was done correct, and that's pretty much it. The remove function is basically to, as you can guess, remove a dynamic field. It accepts, once again, a mutable reference to the ID, as well as the name of the field you want to remove. Afterwards, we can utilize this exists function to make sure that it no longer exists. So this is the assertion that we do. We're moving a bit quick on this one. It's just so that you are familiar with what dynamic fields and dynamic object fields are. So this was how we could work with dynamic fields. You can imagine very many scenarios where you could utilize this in order to extend the functionality of a struct. We said that there is another option, which are dynamic object fields. Now, these objects will be held under an item. As you can see here, this item will be attached to the container, let's say as a child element, because you remember with moves object composability, you can have objects owning other objects. So, more complex scenario, more beautiful things that you can build. Once again, has the key ability, has an ID because it will be an object that will live on chain. And then what about this store ability? Anyone remember what this store ability means for the item? It can be stored. Absolutely. Can be stored in another object, another struct, basically, yes. Since we know that we will be storing this inside the container, we need to give it the store ability. So, part 2, dynamic object fields. We create a new item, and we give a value of 500 for this item. We could just use the same and name it score, it doesn't matter. Then we can once again, but now through a different module. This is the dynamic object fields module. You see, these are two different modules. If I was to click here, this is a different folder, this is a different module, right? The naming is basically the same. We have add, remove, exists function, basically the same naming, because we are actually basically doing the same thing, but we have different requirements. On this requirement, we want this to be depicted on chain. So we're using dynamic object fields. Adding a new field like so, but now providing the item itself, which is an object. Borrowing once again to get the value, asserting here that the value is 500 because this is what we said. So that means that if this assertion passes, the object was created and attached correctly to the container. And afterwards, we are removing it like so, like we did above, asserting that it does not exist. And then we are deleting to clean up our test. Any questions regarding this? Is this clear? Extending the functionality of a struct, adding more fields, either as dynamic fields or dynamic object fields. Cool? Ready to move forward? If so, we are basically done with B2. And as the next topic, we will be seeing B3. We will be talking about the copyability and events. Key store abilities, once again, you already know what these are, we just explained, but we'll go over it again. We're going to be talking about the option, and we are going to be reminding everyone the difference, like passing by reference, passing by value. I think you probably know most of these already, but let's revisit because we can solidify our knowledge that way. So please open B3. Just a quick checkup. Do you guys think we should move a little faster, or are we going just right? Do you think we could move faster, slower, just right, continue as we are? If you think we should continue as we do, raise your hand. Okay, yeah, most of the folks want to continue as we go. Great, so let's see what this is. So once again, I need a volunteer. I want someone to help me see what already exists in this module. Somebody from this table now. Just line by line, what do we have here, and what we'll need to implement, what this file says that we need to extend. Any takers? Anyone from this table? Or I can go through that. Do you want to take it? Yeah, go ahead. I don't think it works. I will give you this.
So first you edit the module, then you import some library, and then you create a constant, the error code, and then you create a hero struct with key. You got two field ID and name. Then you create something like a constructor or initializer.
Yes, can I get the microphone for a bit? Okay, this is the first time we see the init function. What is the init function? The init function, we can have one per module. I remind you that this file is called the module, right? So we can have one per module, and this is run only once when publishing the contract. So you can imagine that we can have logic inside, and we will put logic inside this init function for stuff that we would want to run only once. So for example, that could be I create a registry of heroes, and I want to make this registry a shared object. I hope you remember what the shared object is. It's an object that basically belongs to the network and anybody could use. Of course, you can guard it in a sense and say that only people with that kind of abilities can use this shared object. But theoretically, anybody can use a shared object. It does not belong to anybody. It doesn't have an owner like a normal object. So, let's say that I want to create a registry that has heroes, and I want to make it public. I will basically do that in the init function. That's a good use case of stuff you can do in the init function. Create it and share it, because I want to do this only once. So any actions that you would like in your logic to be executed only once when publishing can be put inside the init function. Continue, please.
Then you have the function that mean the hero with two parameters, name and then the context, and then the function return a hero. So inside you create a fresh hero, just create an object and then return it. Then the min and keep hero, you also have two parameters, names and the context. Then you call min hero function. Then you transfer that object to the sender address. Transfer the ownership.
And basically the rest are tests that we will implement. Yeah. Thank you. So let's see what we want to do in this business case, let's say. What are the requirements? What we should build on this one? Let's say for this example that we want to build an application or a game that has a smart contract behind it. This is the smart contract that we will build, that creates hero NFTs and creates medal NFTs. And we want to actually assign and give medals to the heroes. So the idea is that we have heroes on our game, we have medals, we have a registry of heroes, like a public array that everybody sees that holds these heroes. We have also a storage, a public, let's say, display that holds all the medals. And in our program here, we want to be able to take a medal and give it to a hero, right? So, as you hear this, what do you think should be the main, the structs that should exist in this business case? Once again, we have heroes who get medals. Those heroes are, let's say, a mapping of their IDs is stored in a registry, and the storage, the medals are stored in a medal storage. So, what type of structs do you think we should create to implement this? What, sorry? What do you mean ability? What kind of abilities should these structs have? I mean, for this, we are just starting with a hero. The business case that I explained needs more structs, right? Do you want to take a few minutes and try to create them yourselves? I think that we can say that, of course, we need to have a hero struct. We already have it. You might need to add another field. Of course, we need to create a medal struct, right? To depict the medal object. The medal itself is an object that will be given to the heroes. So, We have the hero. We need to create the medal. We need to create the hero registry, another struct, right? The registry itself will be another struct. And last but not least, the medal storage. So these 4 structs, I will give you like 10 minutes or more if you need time to create these structs. Think about what fields you want to give to your structs and what abilities, right? Key, store, or whatever you think. And what fields? I remind you, hero, medal, hero registry, and medal storage. Is that clear to everybody? Just create the structs like we have in this one and think of the abilities needed. If anyone needs any help while making this, please let me know, right? Medal storage. Medal storage, yes, that's right. Hero medal, medal storage, and hero registry.
This thing, why struct must be public?
Sorry?
Struct must be public.
The struct, yes. You have to declare the struct as public. Public struct, you know. This is
But why?
this is the syntax.
Yeah. So thank you.
No worries. For those who are not coding, I will assume that you have already finished it, right? I hope this is pretty clear. I think I will give like 5 minutes more and we will look into each struct together and we will explain why each ability and each field we will add is needed. Also, please, I wanted to remind you that your attention to these introductory topics is needed because we will go into more in-depth, let's say, move concepts and scenarios and patterns. So you need to really understand this. So please try to code along with us. And if you have any questions or you're not really sure, just raise your hand and I will come on your computer and help you. I think we're ready to show the solution, basically. The solution being these new registries and these new structures, excuse me. So let's go ahead and create the medal struct that would depict the medal objects. What type of abilities it should have? Key? Key and store, that's right. Why store? Yes, that's right, thank you. I just gave it a name. You could give your objects and more fields if you'd like, whatever you prefer. A name is just enough for our example. Now let's create the hero registry. We will be holding in a vector that we saw, the primitive type of, let's say, arrays in move. We will be holding the IDs of the heroes. Theoretically, we could also be holding the hero objects themselves, but we don't want the registry to act as the storage. We'll do that for the medals. The registry will just act like as an on-chain mapping of all the hero IDs that exists from this contract that get minted. And last but not least, let's create the medal storage. Answering a question that was previously asked, of course we can include custom-made types like the medal inside a vector. It doesn't have to be only primitives. So now we have the medal, the hero registry, and the medal storage, and the hero. Let's say that for our contract, we do not want to give anyone the functionality to mint new medals, because I want you to think of it like it's a bit of a mindset shift, that when someone is interacting with your contract, if you have not specifically given a function for them to do something, they cannot do it. So what does that mean? It's not that anyone can extend this contract era and write a new function that mints new medals. If we do not write it and they try to extend it and then republish it, it's a new instance, it's a new immutable, a new contract. So your contract, let's say your business case, you don't want to give the user, the end user of the game, the ability to create new medals. So what does that mean? We are not going to create a mint medal function. We are only going to be giving them the opportunity to create new heroes. We will be manually creating medals where? Inside the init function. Because we said that you can utilize the init function to do things only once while publishing. So in our business case, we will create medals, and we'll see how we'll award these medals, but we will create them only on our init function. So no need for a mint medal at this moment. This is let's say a business case decision. You could theoretically have a game where you could mint more medals, and for that you would have to explicitly add a function. Without this function, there is no way anyone can create medals from your contract. You understand that? Okay, so I think it's time to talk about events. You are probably all already familiar with the concept of events, but what this is actually, it's just another struct type in Move, which we will create another struct that will represent our event, and we will emit an event after creating a hero in our example. Why do we even do that? Because imagine that you want to build a real application that actually listens to these events. Like in any other programming language where you would emit an event and you have an event listener that listens to that, there is a concept while combining, when you want to extract data from Web3 and use it off-chain, where you can listen to these events. What I mean by that? Let's say that when we mint a hero, we also emit an event to the network that is called hero minted. So if I was to have a service in another application or a game that I have built that was listening constantly to the network, and whenever this hero minted event was thrown, it would catch it. So this is what is called basically an indexer. And I set up a service, really simple. We have an example for that on K1. This is a bit of a more of an advanced concept, but if you want to take a look, please take a look at the repository at K1. Of course, you can self-study. We have really detailed README files for each module. So in case you want to take a look at indexers, we won't take a look at that together. But in case you want to take a look, see K1. So just to revise, let's say we are meeting events every time we create new heroes. We have, let's say, a service separate that always listens to these new events. So if I mint another hero on my contract, oh, it will catch it. And after it will catch it, it can do whatever with that data. It can update the database, it can have some custom logic or whatever. So indexing these events really help us bring on-chain data off-chain. Really useful. So for our example, we are just going to be emitting this event. We're not actually going to be doing anything with it, just test it that it is indeed emitted. But let's see how we do that. As we said, just another struct. By design, all events should have the copy and drop ability. Why is that the case? Because when we utilize the function that emits these events, and what I mean by emits is like broadcasting the event to the network. The type given, which we call hero minted, should have these abilities. We know that by design, so we add this. Previously mentioned, copy allows us to copy objects with this type, and drop allows us to just ignore them without the need to consume. So, hero minted has copy drop. Let's give our event some metadata that would be useful for the indexers, like the hero ID and the owner. Who was the one who minted this hero? That's it. This is an event. I think it's time to now include all the newly introduced functionality in our mint hero. Because our mint hero at this moment, what does it do? It just creates and returns a hero. We don't need only that. When we create a hero, of course, we want to emit an event. This is the main reason why we created the hero minted event. And also, what do you think? Based on the structure we previously created, what can we do after we mint this hero? We said emit an event and?
Sorry?
Drop, you said? No, the hero does not have the drop ability. We will not be able to drop it. See the structs that we created. We created some structs a few moments ago.
That, sorry?
The hero object can get a list of medals.
This would not go under mint hero. It will get actually some medals afterwards, but it would not be a good name to have it as mint hero and also award medals, because we want to have each function that we have in our contracts should do one thing, not many. So this mint hero is only responsible for operations regarding the minting, example, the creation of the hero. So we created a hero registry struct, do you remember? So after minting a hero, wouldn't this be a good place to add another entry to the hero registry? If we do not do it here, where will we do it? So we're saying every time you create a hero, add it to the registry and emit an event. This is what's missing. Let's go ahead and do both of these. So in order to add it to the registry, of course, we need to accept as a parameter an object of type hero registry. Of course, because we do not have it here now. So let's do it. As a mutable reference, because we will be mutating this, but not consuming it. So mutable reference. Let's see, the registry has the heroes vector, so we'll do registry.heroes. And do you remember what function we can use to add items? Push back, yes. We will not actually be pushing the hero object, but its ID, remember? So we will do that by utilizing the ID function, that you give it an object and it returns you its ID. So what we're doing here is basically we're saying to the registry of heroes, on the heroes vector, add at the bottom of the vector, at the back of the vector, the ID of the hero that we just created. And the other thing missing is to emit then the event. Let's create it and emit it. The hero minted event has a hero and an owner. Let's give these two values.
Object ID.
I remind you that you could choose to add any metadata that you wish inside this event. We chose to have the hero ID, and we get it like so, like we did on this line above, and the owner. Who will be the owner? The one who calls this mint hero function, of course. So we get that through the context sender. And then return it. Okay, so now our mint hero is basically completed. It used to only create heroes and return them, but now what it does is it creates heroes, it adds them to the registry, it adds their IDs to the registry, and emits and creates the events. Of course, we need to emit this event by utilizing the emit function that exists in the event module, like so. So, create the hero, add it to the registry, create an event, emit the event, and we're done. Of course, we'll need to modify how we call mint hero here because now we added a new parameter, which is the registry. So let's add it here now too. Great. So far we're done. As with the flow that mints heroes, creates events, and emits these events, we are basically done. A new thing that we can introduce at this point is function scoping. You see that every function we have so far worked with, like this mint and keep or this mint hero functions, they are public. Of course, when they're public, that means that they can be accessed by any client, any user. They can just make a move call through a CLI or through integration of an SDK or whatever to access these move calls. If we wanted to have some functions that cannot be accessed by the user, we would make them, of course, private. So let's say that we want to do that thing for the awarding of the medals. We don't want the users to be able to award the medals themselves, but we want to be responsible for that. So we will make the award medal function private, not being able to be called as a move call. So let's go ahead and start with creating now the flow to award the medals to the heroes as private function. We do that by just declaring it as fun, not public fun. Jumping into the next topic. What is option? We will be utilizing option for this example. I shared the documentation on the Telegram group once again, in case you want to revisit. But let's say that option is the way where in move we can, is a special type with which we can give the ability to either store an element of a certain type or just nothing. So imagine in TypeScript, for example, where you have a field that has the value either, let's say, string or undefined. That same depiction can be sort of showcased with option here. So we have an option or element that either holds a medal or nothing. We can do that by option. Pretty simple. You will see which functions we can use to do that in move. And you will see a scenario, for example, that we could utilize this for. Let's say that we built our award medal function in a way where we accept a string. We say, give me a string and I will look up the medal storage, right? You give me a string and I will look the medal storage, and if I find any medal that has the string that you gave me, you didn't give me the object of medal. You just gave me a string. You're saying, award the Medal of Honor. And I will go to the storage and I will be like, is there a Medal of Honor? If there is, return it. If there is no Medal of Honor, return nothing. In order to be able to do that, we will utilize option in move. And I repeat, option gives us the opportunity to either return an element of a certain type or nothing. So let's implement this get medal function that will return an option. We will utilize this get medal function inside the award medal. Of course, because since we want to award the medal, first we need to find it, look it up. So, I want you to take a couple of minutes and follow along, maybe write the function yourselves in order to get more familiar with how we write move code. And afterwards, after you write it, I want somebody to help me understand line by line what this get medal function does. Based on what we did, we said that we are accepting a string and the medal storage, of course, and we are searching for this medal given name into the storage. If we find it, we return it. If we do not find it, we return nothing. So we return something actually. We return let's say an empty option element, which is nothing. We will see how we handle it on the award medal function. But I'll give you some time, like 10 minutes to copy this. And whoever is ready and wants to explain line by line, raise their hand. Just a clarification, because you might notice some inconsistencies. You see that sometimes we just say like the option of medal, which is this is the type, or sometimes we say from the medal, from the option module, get the option type. What we could do, we could just import the entire, we can use, basically, import the entire option module and extract from it the option. So if we were to, at the top of our file, just have another use statement that uses the option, let's do it. we could do that. Do you understand? It's basically the same thing. It's a matter of preference. If I specifically import this, I can just use it. Or I can import it through its module. The first who is ready can raise their hand and go line by line, or I can give you some more time.
Explain the get medal function, right?
Yes, thank you.
Yeah. First, we have the parameter for the get medal function is name and medal storage, and it returns the option of the medal. And it declares the I is the index, and the 0 is the value, and the length is the length of the medal storage.
Of the vector, which is the medals, right?
The medal storage. And we look by the y from the 0 to the length, and we check if the name is contains in the register, and we remove this medal, and we return this medal. Otherwise, we increase the I index, and if don't include any name, we return non-medal.
That's right. So, if we are to reach line 70, that means that we iterated the entire vector and we found no medal that has the same name as the name that we provided as the parameter to the function. So we return nothing. This option none is a function that you can use from the option module to basically say return nothing. And this option sum is the function that you can use to populate the option element with an actual object. So now let's use this get medal function or on a word medal here. So the word medal will, of course, get as a parameter the hero, right? Who will be the one who will be awarded the medal? Again, of course, as a mutable reference, because we will be changing the fields of the hero. Which field? The medals field. The hero has a vector of medals. We will be mutating that by adding another medal, so we need to accept it as a mutable reference, like we did. What about the medal storage? How should we accept it? The medal storage should be mutable. Why? Pop back. We'll be removing stuff from it, but yes, we will be mutating it, so it needs to be passed as a mutable reference. And last, the name as a string, because we will need to pass it inside get method. So now, given these parameters, let's see what we can do. We will call get medal. This will return a medal option. See that I specifically named this variable as medal option, not just medal. It would be kind of misleading if I was to name this medal, because I want to remind you that this get medal function does not always return a medal. It can potentially return a medal if it finds it. If it doesn't, it will return nothing. It will return an empty option. So let's be precise and name this medal option. Give it the two parameters it accepts, the name and the medal storage, and it will do its job. But now we need to assert that this indeed returns something if we want to award it. If it does not find the name that we give it, so it returns an option of empty, we need to stop the flow. So let's have an assertion here to stop the flow in that case. We need to assert that the medal option, so what is returned from get medal, is sum. This function is sum checks that it is not empty. We could do exclamation mark is none, basically, right? It's the exact opposite. We will do is sum. And provide an error code. So you see that assertions are not only meant for tests, right? We can stop the flow by having an assertion here. In case our medal option is empty, this will stop the flow here. We are saying, make sure that the medal option has something, or throw an error. So if we go to the next line, that means we are 100% sure that we were not cut out by this assertion. So now the medal option is no longer an option. It's a medal. It has a medal inside it. So let's award it. From the hero, access the vector of medals that they have, and we will use the append function to actually, I will explain. Basically what this means is that we are creating a vector, a mini vector out of the option and combining it to the other vector of the medals. You could have potentially programmed your solution another way to just extract the item and add this item inside the vector, but this is just another way so you know that you have the option to do that. Here it says that there is unbound field medals that exist in the hero field. Yes, of course, because I forgot to add another field on the hero which will store their medals. So a vector. A vector of type medal. Here, the declaration broke. Let's say that the medals is an empty vector. Of course, when we create a hero, we want them to have no medals. And now we are fine. So we're saying this private function of award medal, which as of now cannot be accessed by anyone other than the contract, will accept the hero, accept a medal storage, and a name of a potential medal. If this medal exists, this getMedal function is responsible for looking up the medal storage and returning if it exists. If it does not exist, it will return nothing. So this assertion will stop our flow, but if our flow is not stopped, we will indeed award the medal to the hero by appending it on their medals vector. Each hero has a vector that holds their medals. Okay, now I want your attention here to these three functions that I pasted. What, in order to save time, what this is basically, it's nothing more than wrapper functions on top of the award medal, but these are public. These will be able to be accessed. We made like three different types of medals: a medal of honor, a medal of merit, a medal of cross. And what we are basically doing here is that we are calling the award medal function with a specific string, nothing more. We could skip this step. If you want to follow along, just copy this solution like for a couple of minutes. And the last step would be to actually populate the init function to complete our flow. Because let's see what we built so far. We have a function that mints the heroes, adds the heroes to the hero registry, then creates an event, emits this event to the network. Then we created a function called getMedal, which accepts a string and returns either a medal or basically nothing. This function is being then used by the award medal function and awards the medal to the hero. But, as we said, we need to actually populate this data and create medals. Heroes, as we said, can be created because we have a minter. But we don't have a way to mint medals. So in order to complete our flow, we will actually be doing that inside the init function. So I'll give you 5 minutes to make sure that you are in the same place as I am. And afterwards, we will be concluding by implementing the init function. And actually, we will be publishing the contract afterwards. We will be publishing the contract and we will see it on chain. If you have any questions while I give you time to copy the solution, please raise your hand. Or I can come to your computer if you have any questions.
I want to ask this why we use pushback instead of append.
because, see, in this example, we have a medal option. We could theoretically extract the medal out of the medal option and then add it with pushback, right? We chose not to do that, and we're just, let's say, if you go inside this toVec function, you will see that it accepts an option of type element and it returns a vector. So we utilize this to show another function that exists on the option. And now that we have a vector, we combine the two vectors by append. You could do that by extracting the medal. You can try if you want to experiment a bit, or later you can try to extract the medal out of the option and then push it back. No worries. I say we continue by doing the last step, which would be the population of the init function, and afterwards we'll have our last break for the day, a quick 15-minute break, and we'll go to the last module. So, let's populate the init function. I remind you that the init function can be run, not can be. It is automatically run only once while publishing the contract. So it's a great place, for example, to create and share objects because you want to do that only once, for example. So let's create our two objects that will be shared, which are the hero registry and the medal storage. We will create a registry, we'll give it a new ID, since this is an object on chain, it should have an ID, and an empty vector of heroes at the beginning. We can share the object by using the share object function that exists on the transfer module, like so. So we create a registry and we transfer it as a shared object. So this is now a shared object. Next, let's create the medal storage. I am assigning it as a mutable because we will be creating also medals and adding them on this medal storage, so we will be mutating it. Saving some time, this is basically every entry out of these three is the creation of one medal. If we go line by line, we see that from the medal storage or variable that we just created, inside the medals vector, push back a new medal that has these fields, the ID and a name. This is called Medal of Honor. The next is Air Force Cross. The other is Legion of Merit. So we create the medal storage. We populate it with 3 medals. No more can be added, right? We have no function to add medals inside the shared object of medal storage. So after we publish this contract and we award these 3 medals, we are done. No more medals can exist, can be awarded. So let's also transfer this as a shared object. I will be commenting out our tests. I think there is not much added value from this. We will get much added value if we try to publish the contract and see it actually on chain, other than devote time on the tests. I think you get the gist on how you could test it from now on. So, let's build our contract. But before we do that, a quick recap on what we built. We had a business case where heroes are minted, medals are created only by us in the init function. We created 3 medals and only 3, and we gave the functionality to award these medals to heroes. This is basically what we did in this small contract. Let's say that this was my task for a partner. I created this contract. Of course, I would have tested it thoroughly. Now we have no tests considering the shortage of time. But let's say that after I tested it thoroughly, I write Sui move build. The build was successful. We have no errors. Then I would go Sui move test, see that I have 100% coverage and that in fact that all my tests pass. And afterwards, I would, before publishing, what would I check? The address that I have as active, so that I know who is the publisher of the contract, and the network that I'm trying to access. I want to publish this on testnet for this example. So let me make sure that I am under the correct address, I have gas, and I am on testnet. Let's check all these things before we publish. Sui client active address. Yes, this is good enough. I have some gas, so I'm good. Sui client active env to make sure that I am on testnet. So we're good. We are ready to publish. We are under the same directory that the move.toml is, I remind you. So the move.toml is under abilities, events, params. So we are under abilities, event, params, and we will run Sui client publish to publish the contracts. Let's see. And we were successful. These are this is the transaction output, and we will see what it means. We see that we have a transaction digest. This is a unique hash for this transaction that we can actually see on chain. Let's copy this and see through an explorer. I don't know if you guys have ever worked with explorers before, but let's see how the explorers can help us. The explorers are basically, let's say, huge indexers in a sense, where they read all the data that is happening on a network, for example, here on Sui. And they give us, in a human readable way, some useful information about the entire network. We will see what we can see through SuiScan, for example. We also have Sui Explorer, Sui Vision. We have quite a few. No, not Sui Explorer, I'm not sure if it exists, but Sui Vision and SuiScan. So this is SuiScan, basically an explorer. This is Sui Vision, also another explorer. It's a matter of preference, what you prefer. Basically different UIs, the same data. So let's make sure that I am looking at testnet because I published my contract on testnet, remember? So this hash, this contract, this and these NFTs, all of that will exist only on testnet. Let's give the internet connection some time, it's lagging a bit. Okay, great. So let me switch to testnet on this Explorer. We are now at testnet's revision, and let me paste this digest. Give it some time. Yeah, I will try SuiScan too. Okay, it's good. Probably internet issues. So, what we see here is basically all the data related to the publishing of this contract, meaning from the sender, who paid the gas, what the gas budget was, the price, blah, 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 and many, many more. What commands we did was just basically publish and transfer, signatures, who signed this? This is basically the signature of my private key, which means that when I run Sui client publish, I paid some gas to run a publish transaction. I signed it with my key pair from my sui.keystore file, remember? Of the active address. So these are the transaction effects. We created objects. This is the shared object, probably either the registry or this is or the storage. Two shared objects, one publisher object, and this is the contract. We mutated, so you can either learn to, in a sense, read these transaction effects, or you could make your life a little bit easier and paste the digest into an explorer and have all this metadata about the transaction and the transaction effects and etc. on a human readable way. So this is basically all that we said. This is a transaction that this was the sender, this is my address, right? It was a success under this checkpoint, meaning this is the checkpoint of the Sui blockchain at this particular time. The checkpoint is, let's say, a moment in time where a batch of transactions is included in a certain checkpoint. Think of it as a block in a blockchain. So we are under this block in a sense. We paid that amount of gas for this transaction. Remember that this was a write operation on the Sui blockchain because we published new contracts. These contracts will exist on testnet forever until testnet is wiped, of course. If this was mainnet, this mainnet never gets wiped, so these contracts would be there forever. Okay, so this is the gas, this is the storage fee, storage rebate. Who paid the gas? Basically, no, this is the gas payment. Who paid the gas is the gas is the same as the sender because we have no sponsor transactions. And we see that we basically published. Let's see about the changes. We have another tab which is called the changes. This is related to all the things that were created based on our publish command. We see that we created an object of type metal storage, right? This is our metal storage, and it doesn't have an owner. It's shared. See here? So we created a shared object. This already happened because we put it inside the init function. Remember that the init function is automatically run once we publish. We published, so we created and shared this metal storage. Something that I want to note here is that you see that this is the type of metal storage. When we were defining a struct, we didn't write all that nonsense. We just wrote public struct metal storage. Do you know why, however, this is depicted like that? It says that its type is 0xC0x blah blah blah, column abilities, events, params, column metal storage. Not just metal storage. The reason for that is actually pretty simple. It makes sense. When we say that an object is of type metal storage, it's not that it's only that. It's this struct that exists in this module, events, abilities, param, who was published by this contract. So if I was to republish the contract, I would get a different package ID, an ID for my contract basically. So the second contract with the first contract would have different types to the metal storage. Of course that makes sense. I don't want everyone who builds a contract and creates a metal storage type or a hero type or a coin type, imagine, to have the exact same type. So the type itself is the entirety of the package you published it from, the module it exists, and the struct name. So all these three make the type. So when, for example, we are saying that for the award hero function, award medal function, we accept a type hero, we accept a type of this specific package ID, abilities, events, params module, hero. Is that clear? We want heroes that were created from this package, from this module, not any hero from other packages or whatever. So the type is the entire long thing. Okay, now that this is clear, we see that we also created an upgrade cap. We will go into detail about this on day 4. And what this basically is when you publish the contract, you also get an object which is called the upgrade cap in order for you in the future to be able to upgrade the contract. We will see how we do that in the future, in the day 4. After that, we see that we also created another shared object, which is the hero registry, published an immutable, which is the package, the contract, and last, we mutated a coin. That means that from the coin that we have, we paid some, which will be the gas, in order to publish the transaction. Imagine that even coins, even Sui testnet tokens are objects under my account. So now that I wanted to spend some in order to pay the gas and publish my contracts, I mutated my coin object. Does that make sense? So basically, this is helpful to decode anything that we did. So if we were, for example, to also have emitted an event on the publishing, like inside the init function, we would be able to read it here. Remember that we only emit the event when we call mint hero. So we have not emitted any events yet. Any question here? We saw how we publish a contract with Sui Client Publish. The steps you need to take before you publish in order to make sure, and how you can read about the transaction details by copying the digest and putting it in an explorer of your choosing. All good? Nice. Let's have a quick break for like 15 minutes, and afterwards we will dive into the final topic of today, which is C1. We will see some patterns. Now you're basically getting started to see how you can build real applications in Move. You will need to know these patterns. So see you in like 15-20 minutes.
You have a question?
No. I come to my friend. Em BBI với người anh thực ra cái cổng của BBI nếu mà anh làm bên truyền thông cho một cộng đồng AI mới, nếu
Có
như
tiền không?
khi mà đề bài lên công ty sẽ có tiền.
Hả?
Khi mà đề bài lên công ty sẽ có tiền.
Ngon đấy.
Nhận kèo KOL hồi trước
Mà anh đó nguyện mà, không nguyện đâu.
thì anh định rủ anh đã kêu bạn đó kêu là xem có lượng thêm ai không, em mới hỏi xem em có nhận không à.
Nhưng mà cái đó là
Còn các phim xây dựng cộng đồng, xây dựng đội
If you want to maybe look at it at your own time, visit the C1 GitHub
ở tiếng nha.
You can maybe look at the C1 submission files and see what.
nhưng mà cái đó là em không biết là cái gì.
Kiểu như xây dựng một cái cộng đồng từ đầu á lên, kiểu tạo một cái cộng đồng, em biết cộng đồng mà đúng không? Thì mọi thứ làm gì bên cộng đồng là nhóm này cộng hết. Chủ yếu là trong mấy tháng đầu tiên, 6 tháng đầu tiên phải có 6 thành viên, có đội tuyển 50%.
6 tháng đầu tiên
Plan hết rồi.
nhưng mà 6 tháng mới 16.000 thành viên.
Tại vì VPI nó từng xây kiểu đó nên dễ mà.
Những người xây dựng cộng đồng như mình là có kết nối một tí, có thương hiệu một tí. Chứ là tự nhiên kêu gọi gì có ai thì ai làm gì giống lại đẹp
Còn phải đây là
không, ý là nhóm cái nhóm đó sử dụng cộng đồng giống như nhóm đó.
nhưng mà nó giống hơn nhóm phổ cập ứng dụng phổ cập AI, tại nhóm thiên về AI.
Rồi em muốn nào mà có khả năng sẽ nhận lương, chứ nếu người làm
Sẽ có lương nếu mà đề bài lên công ty gì sẽ có lương cho các bạn có lương. Hiện tại chưa có lương nha, thì khi mà đề bài lên công ty rồi công ty chấp nhận thì sẽ có lương.
cái này thì em suy nghĩ nhưng mà ý là phải có cộng tác viên
Hiện tại đang tuyển á, anh chưa biết khi nào tốt nhân sự nữa.
sẽ có sách số đó chứ.
Không, tuyển chứ về nhà rồi. Anh đã được, nói chung là chưa rõ nha, nhưng mà em mới đang tuyển, đang rủ rê thôi, chứ không phải là tuyển nữa, mà đang rủ rê.
Để em suy nghĩ tí chứ em sẽ làm không cái gì em có lương ok chắc chắn
Anh luôn vậy thôi chứ em cũng sợ em không làm được, tại em cũng hơi nhiều ý tưởng. Nhưng mà cứ suy nghĩ đi. Em xây format cách nào vậy?
copy chuột copy platform
Ý là em biết format dự án đồ á.
cái đấy mà đâu biết được con gì ra ngoài bắt phút cho con lâu bảo nó ấy cho được
Chứ em mới lâu
không
quá.
em hả em cái này học ấy rồi
đâu phim nào vậy đây
cái
rồi làm cái quân tử mà
cái
Bé của anh rồi lại hết từ tuần trước
lên
rồi.
cái ok rồi vậy thôi
em copy cái UI UX của nó
You're probably one of the first to do that section. Great. Keep us posted. We want to, I would like to tell you when I
Mọi người đang nghỉ ngơi xíu nhé mọi người ơi, chiều sẽ tới mua Portland.
So everybody who attended this bootcamp will be invited to this, let's say, Sui Vietnam Index organization. And theoretically, you could upload your repository from there or whatever you choose.
You have some rice. Rice? You have some rice.
Great. But I'll be taking a look at Vietnam soon. It seems like you guys are so bright.
I was a lecturer last few months. I got two of my students got job at Sui McDonald's. So
Really?
I have to build some like seal and
Yeah, yeah. Well, probably I'll be meeting the commander this week. Nice. I'll send you your regards. Good to meet you.
one photo.
Yes, let's do it. Let's send it on telephone.
Yeah.
liệu ha.
Dạ.
Bài gì ấy?
Câu nói chuyện lung tung thì em hay.
for the gas station, I only know pretty much the concept. ZK. So there is a gas station definition too.
Yes, in the sense that you
There are some services where you can use actually. I don't know if you can give the ability to sponsor a wall as well, for example. Probably there is some issue regarding how you can put all gas station. Remember when we talked about this when we did the Campus, we had a Sui gas station.
but also let's say that you were not actually to again, it's an issue with your I think maybe you can explore into the concept of having your own gas station. So you use
Do you know anybody working on that?
any example? No, but I can find. I think Holiday Park has worked that before. I can ask her to let you know when we will do the next one. I will send you a link to the gas station in case it helps. Okay, so custom gas station should be
Currently, if I can find a way to build a wall, base station, I can have a big wall. Yeah.
This is a second problem that you face often, right?
Yeah.
Okay, we can discuss it. Hello, hello. Ready to continue? Let's continue. So, the final module of today will be C1. We will be introducing some patterns like the capability pattern, one-time witness and working with a publisher, as well as the hot potato pattern. And after that, we'll be done for today. After a quiz. Of course, you see that we have a quiz. Today's quiz will be technical, based on all the things that we saw today. So, let's start with C1. Please, if you want to follow along, navigate into C1. We will start with the capability. Once again, I will be sharing documentation from the Move book into our Telegram group chat regarding capabilities. Let me do just that. to resources and operations. So let's say that I build a contract, I want to have public accessible functions, but not to everyone. Only some. Who would be those some? I can set up a special type, a special struct. For example, an admin cap, as you might have heard it, because it's a quite known term, an admin cap, which would be an object of a specific object that is given to specific people, and only if you hold this object, you have the capability, thus the pattern name, to access with my transaction, to access with my function, excuse me. So, for example, here, you see that I have a struct called admin cap. This is an object, has the key ability and an ID. This is an object that will live on chain. Imagine this as your passport, let's say. And I say that only those who have a passport have the ability to call the function which is called take aeroplane, fly with the aeroplane. If you do not have the passport, you are not able to call this function. So, for example, we have this new function here, and we see that this function requires as a parameter for you to show me as a reference. You pass the admin cap as a reference. You need to show me that you have an admin cap object. You don't need to give it to me. I am not consuming your object. I'm not taking the capability away from you to use it for another time. You just need to show me. Look, I am an admin. Here's my admin cap. And now I can interact with this function. If I'm not an admin, that means that I do not have an object. I'm not an owner of an object that is of type admin cap. So when I am to call this function, either through a CLI or a DApp or whatever, I will not be able to provide this admin cap. So the call to this move function will fail. Understandable? Let's write some move code and explore with this capability pattern. So please open C1 like I have, capability, and let's fill out the rest of the contract to showcase the capability pattern. Cool, so we see, once again we have a hero, but now we also have another struct called the admin cap. This is what we said. This is the object that you need to hold that is specifically, we will see how we'll handle to specifically give this object to certain people. We will not give you the ability, we will not give the ability to anyone to mint new admin caps, because that would never make sense. So we give admin caps to certain people, and only those people can then have access to certain functions in our contract. So we could have a contract that has admin functionality only for the admins, and functionality without that it's not access, it's not controlled. The access is not controlled, so it could theoretically be accessed by anyone. So we have an admin cap. Let's fill out the rest of the init function first. It says that we need to create an admin cap and transfer the admin cap to the publisher wallet. So whoever publishes the contract will get an admin cap. A reminder that this init function is executed only once upon publishing. So let's go ahead and do that. So create an admin cap. and then transfer to the publisher of the contract. Who is the publisher of the contract in that sense? In which address will I transfer this? I am inside the init function. Who? Exactly, the context sender. And I want to remind you that publishing is another transaction, right? It's just a transaction altering the state of the network. So whoever will be the sender that will be returned from the context here in this init function will be the one who will be publishing the contract. So I can just go ahead and give it to the context sender. And that's it. That's all I need to do in my init function. What I'm saying is only the one who will publish the contract will be set as my admin, and therefore he will be the only one who will have an admin cap in order to call create hero, transfer hero, new admin. You see, these three functions that as a first parameter require for you to give an admin cap. As you see, they are assigned in an underscore. That means that I will never use this admin cap. I don't care to actually do anything to this admin cap. I'm just assigning to an underscore. I just require you to show me that you have it. As long as you show me that you have it, you can go ahead and do the rest of the implementation and interact with the rest of the implementation of this function. Let's just really quickly fill out these three functions. Just minting like we always have done so far, create a new hero and return it. Transfer it, transfer it. And the last is a bit of an interesting function. You see that we are asked to implement new admin. This is basically a way that we can extend and let's say future-proof our application in the sense that we want the admins to be able to create new admins. Almost all CRM projects or every project that you use right now, for example, like GitHub, if you have a GitHub repo, GitHub organization, as long as you are an admin, you can create new admins. So let's say we want to mock this functionality in our contract. We have a new admin function that says that as long as you have an admin cap, feel free to mint another admin cap and transfer it to whoever you wish. To is an address, whoever you wish. So, if we did not have this function, that means that we will, for the life of this contract, we would only have one admin cap that would be created once publishing. Now that we have this new admin function, all admins can create new admins. All clear so far? Exactly how we saw before, just minting some new types of objects, but that now the only newly introduced thing is that we are controlling the access to these functions by requiring you to show me that you have an admin cap. You could name, theoretically, you could name this struct however you like, but it's a convention, it's a good practice to suffix at the end of the struct name the cap, because this is the capability object. So it could be like any cap or whatever. Let's go ahead and implement the tests and showcase and see that what we did just works. Then we are asserting, oh, are they already implemented? They probably are. Okay, so we do not need to do anything for this first test or the rest, or no, we only will implement only the last one. But let's run each one of these to make sure that we are indeed correct. Let's run test publisher address gets the admin cap. And let's go through each line one by one. So, line 49, do I have your attention, please? Line 49, we are initializing the test scenario like so through the begin function. We give the initial actor, which is the admin, and then on the next line, line 51, we are saying, please assert equals is another assertion function that you can use that basically says, accepts as an expression, the first argument is an expression, as you can see, and the second is the expected value of the expression. So we're saying, from the test scenario, utilize the has most recent for address function and give the type. What does that mean? It means that make sure that the admin that I give here has an admin cap and give me the most recent. This is a test utility function you can use to implement your tests. Imagine in a sense that you are seeing that this returns a Boolean value. So it would return either true or false. So I'm saying has most recent for address. Who, the admin, has most recent, give me the most recent admin cap for the admin. Make sure assert equals that this returns false. Why? Because this is just a dummy address I just created. It should not have an admin cap. If I run the init function, then it should have an admin cap, right? So after I write the init function, I'll return to this. After I write the init function, the outcome of this expression should be true, because now after the init function, we minted and transferred the admin cap, so now you should have an admin cap. And this is basically the test on how we can see that before you did not have any, now you do, we're good. And now we'll return to line 55. Anyone have any idea what this could be? ts.next transaction. And we give the admin. This is a newly introduced concept, so I will just go ahead and answer. This is basically so that this next transaction function, I want you to remember that we are on a test scenario, right? This is a test scenario. These are all needed when you're writing tests, not actual move code for your contract. This will not be executable by anyone, only the tests. We are saying that go to the next transaction. Basically, since we know that the previous line, the init function, if we were to run the init function on the actual network and not inside the test like we do here, it would change the state of the network. How so? Because it created another object that is called an admin cap. So if we do not include this line, our test would not be able to refresh its memory and now know that we have created new stuff on the line above. So now that we actually created stuff with this init function, we need to specifically call this next transaction and be like, refresh your memory. Because as I told you yesterday, this test scenario imitates, let's say, simulates the network in a sense. So after I run this init function, new stuff were created to the network, to my imitated, simulated network. So refresh your memory, and if I was to remove this line, this assertion would fail because it would not be, let's say, updated with the fact that an admin cap now exists. Do you get it? So I don't have an admin cap here, and I shouldn't have it. I call the init function, network, please be informed that I made some new stuff, so you need to update in that sense. Now, you should have an admin cap and the test. That's basically it. And of course, we saw that this test passed. How about the next one? Let's also run the next one, and for this one, somebody else will explain it. This is also successful. Who would like to explain line by line based on what I just said? If you are not sure about the entire thing, you can start, and when you are unsure, you can let me take over. Who wants to start? William, is there an idle microphone there? Okay.
So, from the line 96 to line, the first is like begin that scenario with the sender admin, and then we init the contract with the that scenario that we set up alone, and then we move to the next junction with the same sender to reverse the state, and then we take the admin cap, take the admin cap and assign it to a value.
You can take this.
And then we call the create hero function with the admin cap that we take earlier with the name and the contacts into the function. In the next line, we assert that the created hero have the same name that we expected, hero one. And then we return the object admin card that we have taken earlier to the sender, which is admin. And then we we destroy the hero object, return from the create hero function, and we end the JSON scenario.
Thank you. Correct. Yes. Just a quick reminder, the only reason why we were able here to just go ahead and destroy the hero is because if we take a look at the hero struct, wait a second. The destroy hero, let me see this function. Yeah, this is from test utils. So, of course, since we were in a test, we are able to do that, or we would not be able to just go ahead and destroy the hero. We are consuming it, that's why. The next is basically the same thing, but now we're testing the transfer hero function that we also have created. And how about the last test? This test is called test admin can create more admins. Remember that we said that as long as you have an admin cap, let me find the function. As long as you have an admin cap, you can create new admins and transfer them to whoever you like. So what this test wants to see is that the fact that you are able to do that. So let me go through this line by line. Begin a test scenario. Call the init function with the transaction context. So basically, the sender will be the admin, since we are getting the context from the test scenario, and we have begun the test scenario with the admin. That means that whoever will be the sender of the init function, in a sense, is the admin. So refresh the state, get the admin cap with this helper function from the test scenario, mint a new admin, give it to admin2, which is a hard-coded dummy address that we have declared a few lines above. Return the admin cap to the sender because we need to consume it, as we said. This is how we can mock that through the test. Return it. Afterwards, refresh your memory once again, but now with the admin2 as the actor. So who will be the next one to basically sign the next transaction. So now that the admin2 is the next actor, assign a variable from the admin2 to admin cap2. Then let them create a hero. Who is the one who is creating the hero? Admin2. So let them create a hero and then assert that this hero was indeed created by looking at the field name. Cool. Then return the admin cap2 to the sender, destroy the hero, and end the scenario. So what we did, we created a new admin cap. We gave it to admin2, and we said, admin2, now that you have an admin cap, create a hero. If this passes, that means that admin2, initially, when we began this test scenario, initially they had no admin caps. Admin 1 gave admin 2 an admin cap, and after they gave them an admin cap, they were like, admin 2, now you made the hero. And they do just that. Let's test it. And it passes. Great. We're pretty much done with showcasing the capability pattern. Any questions regarding that? Just a way to control the access to your functions. If there are no questions, let's go ahead and jump into the next topic, which is basically the publisher. Once again, we will start by showcasing that for this concept as well, there exists a dedicated page on the publisher authority on the movebook. I am sharing the link on Telegram as well. Publisher authority. In application design and development, it is often needed to prove publisher authority. This is especially important in the context of digital assets, where the publisher may enable or disable features, certain features, for their asset. The publisher object is an object defined in the Sui framework that allows the publisher to prove their authority over a type. I want your attention here. It's an object defined in the Sui framework. That means that objects with the type of publisher exist and are created on the package module of the Sui framework. So it's not that we will have a publisher type of our own that we will create inside our module. We will use this type that exists on the package module of the Sui framework. The admin capability and the publisher object are taught together because I want you to think about the publisher as just as another way to access, to control the access to your functions. But the publisher would be, in a sense, a bit more strict because only one publisher exists, right? A singleton, more of a singleton pattern. So, let's see an example on how we can utilize the publisher and how is it different from the admin cap that we just saw. If you want to follow along a code alongside me, please open the publisher folder and the hero.move module. This is a bit of a tricky concept. I want your attention here so you can understand it. Let's open the package module and see what this is all about. I searched for the struct with the name publisher. You see that objects of type publisher exist and can be created only through package.move. I'm not sure if you previously mentioned this, but you cannot, if a module is not giving you a function to construct or mint objects of a certain type, you cannot just create them outside of the module. So, let's say that we have the package.move module, which has this type of public struct publisher. And I want to create this, an object of type publisher on my hero.move file. If there is no function inside here that allows me to create a new publisher, and then I can just call this function, if there's no function like that in this module, I am never able to create objects of type publisher. So, of course there is, and we will see what this function is basically. Let's see how we can actually create a publisher by filling out the init function. Create publisher and transfer it to the publisher wallet. Let me go ahead and search, for example, I will search a function that I know exists on this in order to create a publisher, because as we said, we cannot just go ahead and create a publisher here. We have to do it through a function that is given by the package module. Which is called claim or claim and keep, even easier. Claim just returns a publisher, but claim and keep creates a publisher, but also transfers it to the sender. So we will utilize claim and keep to create a new publisher for the sender. So, we are coming up on one new topic, but let's take it step by step. We said that in case, I want to reiterate on this, in case you want to control the access to your functions, because as we see here once again, we are requiring you to show me that you have the publisher object, like we did with the admin card. Show me that you have the publisher object. But there is a small difference. You see here that we have not assigned it to an underscore. We need to do a certain action with the publisher object that you give me. But as a first step, see that it's the same in the sense that you need to show me that you have a publisher object in order to access my function. Let's see how I can get this publisher object through this claim and keep function. This claim and keep function, let's see what argument it accepts. It accepts an one-time witness and the context. What is this one-time witness? it would be best, I think, if I showed you through that documentation. Let me just open it. Oh, we have a broken link on the movebook. I will make a note of that. Oh, or I can just go through here. Okay, so a one-time witness. A one-time witness is a special type of witness that can be used only once. It cannot be manually created, and it is guaranteed to be unique per module. A one-time witness is basically a struct that follows these rules. Has only the job ability, no fields, not the generic type, and named after the module with all uppercase letters. We will see why this is important when we see the effects from the explorers, to make this a bit more clear. So we need to provide a one-time witness. A one-time witness, as we said, is a struct that follows these rules. So let's go ahead and create a struct that follows these rules, which is basically this. It's a struct that has the job ability, no fields, and the same name as the module, but with all uppercase. So let's give this as a first argument. So now we are able to create a publisher and transfer it to the sender, because this claim and keep transfers it to the sender. Now we have a publisher object theoretically as the sender, and we would be able to call these functions. But, another small thing, it's not just like it was with the publisher, the admin cap object before. We need to do some sort of assertions related to the one-time witness, and this is why you will understand why we need the one-time witness, to make sure that. Remember when before we were looking at the Explorer and we were seeing that a type of an object is basically the package ID, then the module name, then the struct type. So in the previous case where we were actually requiring an admin cap, we were saying, I want an admin cap from this module, from this package. So I was 100% certain that these admin caps came from my published contract. But now that the publisher is not from my contract, from my module, the publisher is from the Sui framework on the package module, that would mean that if I was to see a publisher object on chain, its type would be 0x2, which is basically the contract address for the Sui framework, column package, column publisher. What is the issue that exists from this? Yes, in a sense, but what the real issue is that I could have made a contract myself on mainnet. I could have created a publisher that is given by the Sui framework. I have a publisher object now. And then I go to your contract where you require a publisher, and I'm like, here's my publisher. But it's from another, I got this by another contract I created. So in order to guard against this, because the type is generic, it comes from the Sui framework to the package module to the publisher struct. So in order to guard against this, we are using the one-time witness. So we are saying, we are basically going to make an assertion here and make sure that this publisher because this is not enough. This just says, give me any type of publisher. If we do not assert that this publisher was created with the help of the hero one-time witness, we are never sure that this publisher came from this contract. I will repeat on this because this is an interesting concept, and I want you to realize the difference with the admin cap. Once again, the admin cap is an object that was constructed, so its struct definition came from our contract. We specifically said public struct admin cap. So when we create objects of type admin cap, we publish our contracts and we have objects of type admin cap. Its type would be package ID, hero, admin cap. So we are good. We are good in the sense that when we require you to show an admin cap, you are showing the specific admin cap that you minted from my contract. So in that sense, we are guarding access and we are good. But now let's say that we need to strict the access to only one person holding the publisher object. That would be only who published the contract. We saw that the publisher struct definition exists under the package module from the Sui framework. The package module gives us this claim and keep function to create publishers and transfer them to the sender. So now our sender has a publisher object. If we were to look at our wallet and see the asset called publisher, its type would be 0x2 package publisher. So if I made a contract regarding a game and you made a contract regarding used, for my case it's hero, and I want to remind you it's not just hero, it's hero that comes from this contract, right? It's not just these 4 uppercase letters. And yours would be DeFi if you named your module DeFi, DeFi with upper letters. So since we want to guard the access to our functions now with showing the publisher object, we also need to make sure that this publisher object did not come from your contract, but from mine. And we can make sure of that by utilizing the one-time witness. Let's see what this assertion looks like. Is it clear now? Is it good? I shared some documentation in case you want to take a further look or you want to digest it and follow back on this tomorrow. Feel free to ask me to do that. This is basically the line that helps us, that saves us, in a sense. Assert that the publisher you gave me comes from the module hero. That's enough. So if you were to call this create hero function, but provide me your publisher, this assertion would fail, so our flow would be finished. I accept publishers that only used this one-time witness. Does that make sense? If you forget this line, any publisher can have access to your contract. That's bad. That's a security risk. You need line 21. Only publishers that were created from this module. After that, just mint, same for the transfer. We won't waste time on this one. Do you have any questions? I will give you like 10 minutes to digest on this. Think about it. If you want to open the documentation, maybe think of a question that you have. These were 2 ways that we saw that we can control the access to our functions. The publisher one would be stricter, since there exists only one publisher object. With the capability pattern, you can mint multiple if you wish, multiple admin caps, for example, and they are different in how you should handle them. The admin cap, you can assign it to nothing because I just require you to show me that you have it. But with the publisher, you have to do an assertion afterwards to make sure that it was created from your contract and not from another contract. Does that make sense? Okay.
About the publisher.
Yeah.
If I code the admin cap, but I don't code the function like transfer or give admin cap to someone else, and I could just use the admin cap to prove that I am the publisher, right?
Theoretically, if you only create one and you give it to the sender inside the init function, it could act as the same way. Yeah. Yes, you can do that too. If you have a no minting function of new admin caps, it would act in the same way. So it's a matter of preference.
Kêu nếu như
I think today we went a bit deeper than yesterday, of course. That's how we should. I think it's enough topics for today. We will leave the hot potato pattern to start the day tomorrow, so you are also fresh. And I think we have enough new things learned today to go ahead and test our knowledge with the quiz, right? Today's quiz is technical, so I need you to pay attention at your screens because there will be some code snippets that could be a bit small here and you will not be able to read them, for example. Let's see if you understood the topics that we touched on today. I hope you did. If not, if we don't have good enough quiz results, we'll stay here and do the entire thing again. No, I'm kidding. We will not, of course. Of course, I'm kidding. But feel free to ask any questions. If you see that after the quiz you have not completely understood everything that we mentioned today, feel free to reach out. So get ready. I will pull up the quiz right here. I will also share it on the Telegram group chat and see how we did today.
It's okay. See you tomorrow. See you. Bye.
Everybody join the quiz. We have 10 people who have already joined. There's more than 10 here, so please go ahead and join. We'll wait for everybody. I'll also send the link to the chat on Telegram. I will wait just one more minute. Those who have not, please join. Even the folks online. Okay, so let's have your attention on the screens. I will start the quiz in 3, 2, 1, go. Wah, wah, wah. We see that we have an ID field but no key, right? No key. We have an ID but we're dropping a value. This is not correct. Next one. Fast, fast. This is easy. Fast, fast. Everybody, get this fast. Come on. Every second counts. Fast. 2 people have not answered. Come on, fast, fast.
Nice.
No wrong answers. That's good. Let's see. Will this test pass? That's right, it will indeed pass because the pebble reminder has the drop ability, so we can just create one pebble inside this test function, do nothing with it, ignore it, and we will have no issues since it has the drop ability, so it will pass. Next one. Good job, guys. Multi-selection. Both of these are correct. You can indeed specifically assign the type by column type, or you can skip it. Question 5, let's go. Will this code block compile? No reason not to, right? This is valid move syntax. Next one. That's right. Remember, of course, that we have this debug keyword that is also printed. Next one. have different answers for this one. Not many got it wrong, right? This is not the correct. This has the new keyword that we do not need to use. This is the correct way, right? Let my vector, which is of type vector that includes unsigned integers of type 8, with 8, an empty vector. This is the right way to initialize a vector as empty. What is the output of this test function? That was a trick question. We see that we have not defined this vector as a mutable, so we cannot change its contents. So when we try to do that, we will get an error which will say invalid mutable borrow of a mutable variable myvec. If we were to have set this as let mutable myvec, the output would be 1, right? Debug 1, the length. But this was a trick question. You see, guys, today we have a bit of a trick questions. Pay attention on the next one. 2 answered correctly. Congrats to those who did. Good job, guys. What is the output of this test function? Let's see once again, not that good results. What did most of you answer? Most of you answered error. Actually, if this was to error, it would not compile at all, not just debug the first one. So, the print would be 2, because the length is 2 for the first one, and the second would remember that this pop back function returns an element. Do you remember that when we were seeing this pop back function definition, it returns an element? So this is basically number 20, and this is what we would be printing. Final question. It's everybody's game, I think, right? So do your best on this final question. What is the output of this test function? We saw this earlier. I hope all of you get this right. Good job, most of you got this right. Just a reminder, the length, of course, a number. Then the string, then it's just the reference to the vector. We would not print the entire vector. So let's see the results. Who won? Who are our top 3? Please raise your hands. Who's Fu? Good job. Who's Koi? And Lam is you. Oh, so we have the same three winners. Good job, guys. Congratulations. Probably for anyone wondering, probably these are the lucky seats. If you want to win tomorrow, maybe still their seats. This is the lucky seats. They see everything so good because they have the huge screen in front of them.
Can you show the full leaderboard? I want to screen
The results, you mean? Yes. Good job to everyone. Thank you for today once again. A bit more complex topics, but I would say not really. We will see more complex stuff. I want you to make sure that you feel confident with what we saw till this point. If you do not feel that confident, make sure to either look at it on your own time, send me a DM on Telegram after this message, after this session, of course. Feel free to do whatever. This session is for you guys, so I want to make sure that you get the most out of it. Thank you for today, and we'll see you tomorrow at 10. Thank you. Sorry? Nice. Good job, guys.
Lỡ ồ xin luôn.
Guys, any question, just send me a message. I will be online by the end of the day today. So any question, just shoot me a